Topic 4. We're continuing with modern oceanography from polar exploration to satellites. Contemporary oceanography makes use of modern technology. So in the 20th century, it became possible to start exploring the deep ocean floor and the polar regions. Polar exploration advanced ocean studies. We got new ships that were ready for new tasks, and new oceanic institutions were founded. So one of my favorite stories is the polar exploration of Fridtjof Nansen. Nansen crossed the Greenland ice sheet in October 1888, and he became quite famous. This time there were already newspapers and the telegraphs, and so his explorations became well known. He wanted to prove that there is no Arctic continent. Antarctica had been discovered a long time ago, and people knew that Antarctica was a continent because you could see the mountain ranges. But no one had really explored the Arctic Ocean. So Fridtjof Nansen added to our understanding of ice drift, of meteorology, of the oceanic conditions of the Arctic Ocean. So he talked the Norwegian government into building him a ship, the Fram. And he had this idea that he could sail up to the New Siberian Islands, wait till the water freezes in the wintertime, have his ship frozen into the ice, and then drift in the frozen ice across the North Pole and come out between Greenland and Iceland. So here is the ship, the Fram. It has sailed further north and farther south than any other wooden ship. So here's a photo of the ship being frozen into the ice. It must have been horrendous because the ice was pushing against this wooden boat, and it was just creaking and shifting. It was horrifying. And I put a book on your reading list that I posted. I recommend that you take the time and read the book if you like explorations. So here is a map of the routes of the Nansen expedition. So he set out in Norway, so that's on the left-hand side of the map. And he's followed the red line. So this is how they sailed the Fram through the open water in the summer. They got frozen near the New Siberian Islands towards the right side of the map, and they followed the blue line. And you can see it's a squiggly line just as the ice drifted. He at one point realized that the route was going south again, but without reaching the North Pole. So he and one other guy set out on skis. They left the ship and they were skiing towards the North Pole. They came to 86 north and they realized they're not going to make it to the North Pole. So they turned around, but they couldn't meet up with the ship anymore because the ship had moved on. But they were lucky that they got to the Franz Joseph lands and they pitched tents. And then the next summer, they were rescued by a team of British explorers. The British team took them back to Norway. Back in Norway, they were celebrated like returning from the dead. And they were celebrated, telegraphs, newspapers all over the world. The day that Nansen and his friend arrived in Norway, the Fram became free of sea ice and was back in the North Atlantic, which is that yellow route, and they arrived in Tromsø. So it was really an incredible story that no one of the expedition died. So here's a photograph of the Fram in the background, and Nansen and his friend Johansen left the ship to ski to the North Pole. Here's an artist impression of Nansen and Johansen's northernmost camp on April 7th, 1895. And here's a quote by Nansen. "I have become more and more convinced we ought to turn around." And it was a good time, and like I said, everyone survived that expedition. The Arctic Ocean is still very much being explored and of big interest. And we're going to be talking about climate and throughout the semester. And the Arctic Ocean and the sea ice is really an important climate feedback. As long as the Arctic Ocean is covered by sea ice, the surface is white, and a lot of the incoming solar radiation or the energy from the sun is reflected back into space. But if the sea ice is gone and you have open water, that energy is going to be absorbed and it's going to be heating up the planet even more. The next thing I would like to talk about is the Meteor expedition. Now we're in 1925. It was a ship that had modern optical and electronic equipment on board, and they had an echo sounder on board. And they went out on a 2-year expedition into the South Atlantic. So an echo sounder emits a beam of sound waves from the ship that travels to the bottom of the ocean that is reflected back to the ship. And by the time it takes for that sound wave to reach the bottom of the ocean and come back, you can calculate the depth of the ocean. And while they were crossing back and forth in the South Atlantic, they recognized this peculiar mountain on the seismic profile shown in the lower left image. Before that, people thought that ocean basins look like bathtubs. So you enter the ocean on one coast, the ocean drops off, you cross the ocean basin, and you come back on the other coastline. It just looks like a basin. But by going back and forth, they found this ridge. And so they knew that the ocean was not shaped as like a bathtub. And through that, they discovered the Mid-Atlantic spreading ridge. And we're going to be talking later on about plate tectonics. And the Mid-Atlantic spreading ridge is where the ocean basin spreads and new seafloor is generated. So the HMS Challenger in 1951 took depth measurements of the Atlantic Ocean, Pacific Ocean, the Indian Ocean, and the Mediterranean. So we started to understand much more about the ocean. In 1960, the Challenger Deep and the Trieste, that little submersible, they reached the maximum depth of the ocean at about 35,000 feet. It's the deepest known part of the ocean, the Mariana Trench. That was a new record. So here's just an image what the Mariana Trench looks like based on a model. So the deepest part of the ocean. And of course it's pitch dark because there's no sunlight penetrating that deep into the ocean. Technology continued, and now satellites have become an important tool in oceanography. Satellites can measure sea surface heights, and they can get data about sea temperature and salinity and so on. A really, really important tool in oceanography. The Glomar Challenger in 1968 drilled into the ocean floor at 6,000 meters of water, and they provided evidence for plate tectonics. Oceanic institutions arose to oversee complex research projects. And so 3 of the most prominent oceanic institutions in the United States are the Woods Hole Oceanic Institution, Scripps Institution of Oceanography, and Lamont Earth Observatory in the Columbia University. So before we finish up this chapter, I have a few quick concept checks. So the first scientific expedition to use an echo sounder was the Meteor expedition. We showed that the Arctic Ocean is not a land mass. Fridtjof Nansen. Satellites can measure the height of the sea surface from 835 miles above Earth. That is true. The Topic Poseidon is a satellite orbiting the Earth in an orbit that allows coverage of 95% of the ice-free ocean every 10 days. The satellite uses a positioning device that allows researchers to determine its position to within 1 centimeter, which is 1/2 inch of the Earth's center. The radars aboard can then determine the height of sea surface with unprecedented accuracy.